Okay, the next subject then, the maintenance profit impact. Maintenance profit impact. What this says is it says that maintenance has an impact on profit of the organization. Maintenance has an influence on profit of the organization. Now I think that makes sense because if you do good maintenance, of course, you are producing more capacity effectively. Now some guy says, no, but you cannot do that because that just means that you do less bad maintenance. Okay, positive or negative, how you want to look at it. If you like to look at it differently, it's okay with me. But the point is that when you don't do good maintenance, you won't have as much profit. So whether you look at it this way around or that way around, the fact is that maintenance has an impact on profit of the organization. I think of it as a positive impact. So the first thing in which you influence the profit is through the level of prevention. The level of prevention. Now we say that the level of prevention indicates the effort that the maintenance organization applies in preventing failure from having a negative effect on the organization. So you can put little preventive effort in, or you can put much preventive effort in. And what we're saying is, the more preventive effort you put in, the more you have a positive effect on the profit of the organization. It includes all preventive attacks, such as regular services, inspections, condition measurements, and scheduled component replacements. So all of those are preventive attempts. So when I service a piece of equipment, I service it because I want it to last longer. I want to prevent it from breaking. When I do inspections, I have the idea that I may find things that will go wrong, and I can repair, I can prevent them from going wrong by doing taking proactive action. When I do condition measurements, exactly the same thing. I just do it by more complex means than by inspections. I just use technology. I measure vibration, or I take an oil sample and I have it analyzed and so on. So I find out certain things that are busy happening in the piece of equipment, and I take precautionary action to prevent that from happening, from being a failure. The other one that we have there, scheduled component replacements, exactly the same idea again. When I know statistically, because of my history, my failure history, all the stuff that you did in 780 or in 781, the type of failure analysis, where I then know what are the qualities of my Bible distribution, then I can calculate when should I replace that thing preventively. How often should I replace it? If I cannot make use of condition measurements or inspections or services, but it's maybe very possible to make use of component replacements, then I do that in order to prevent unnecessary breaks and unnecessary costs. The level of prevention being practiced directly impacts on the production capacity and thus on the profit of the company. So the more I prevent, the more effective capacity I get. So I get more capacity to produce because I have more availability of equipment, I have higher reliability of equipment, and so on. So we say that one thing that we can also influence is availability. We say availability is the proportion of time that a technical system or a machine is operative. That is that it is in the non-failed state. Now we have a little picture here. We have some period of time which we call T total. And we have availability defined there then as being T total minus the downtime portion of that full time divided by T total. So that gives us what is the availability of equipment that was produced. We say that if T total is the total possible time during which operations can take place, at least the downtime incurred, both planned and unplanned, then availability is given by that little formula. One can also say that the availability is the uptime as a percentage of the total time. So, uptime as opposed to downtime. The maintenance function must provide at least an acceptable level of availability to operations. And what is an acceptable level? It's that level which adequately supports the operations plan and was agreed on at a certain price during budget time. So during budget time, you will find that production says, well, in order to produce what we need to produce, we've assumed certain production rates and so on. We need such and such an availability. And maintenance then says, okay, if you want that availability, we can do it at a certain price.
So, in this case, wouldn't it be wise that the company states exactly what is it that they're chasing in terms of whether they're chasing reliability or availability? In that the system might be available for a long time, but it's intermittent. It is available for 2 hours, it fails, 30 minutes, it's going to maintain and then start again. And then when you look in terms of the total time, you think like, oh no, it's available 70% of the time, then it's okay. But it's not reliable. You can't leave it to work on its own. It's going to come every 30 minutes to take it.
Can I answer it a little bit later?
Alright.
When we get to reliability.
Nice.
Good. So we say to maximize maintenance's contribution to company profit, it should be the objective of maintenance management to provide maximum economically viable levels of availability. So we're saying that if maintenance can provide higher availabilities, and if that can be utilized by production, it should be done. Because it will produce more output, which can be sold, which will make more profit. The only case where that cannot be done is when production has a certain fixed capacity that they have to deliver. In other words, there's not a flexibility in terms of you cannot sell more, the market has some restriction or whatever. And sometimes you get that type of situation, but typically that is what should take place. Maximum economically viable levels of availability. We say that availability is positively correlated with the level of prevention. In other words, the higher your level of prevention, the higher the availability becomes. But of course, as with any good thing, later on it flattens out. You get less for more level of prevention. You get less of an increase. You still get increase, but less of an increase. Mean time to failure. That's now reliability. That's where we get to that. We say that availability gives an indication of the average efficiency of the company's equipment maintenance. However, it does not provide a measure of the reliability of the maintained equipment. Now we explain that. It does not measure the regularity with which maintenance is required. It's also important to the efficiency of the production process to have long average production runs. And you said, well, one should make a decision regarding that. In some situations, it's not good enough. For instance, in the military, when I have a cannon that goes out on a mission and has to go and do a job blast something and then can come back, then what I want is I want what they call mission reliability. I want this cannon to go out there and come back. Maybe a cannon is not that good. A ship goes out of the harbor, goes to a far off place, has to go and do a mission, has to come back. And you want it to be reliable such that it will go out there, do what it needs to do, and come back without a breakdown. When it steams into the harbor, it can break. It's okay. But it must do its full job.
Maybe an example to illustrate that is that if, say, a unit was off because of a separate defect, and you can highlight that to production that, okay, there's another defect that you saw that it needs to be addressed before the unit is brought back to service. Production may make a decision to that we need this unit available now, knowing very well that if we do return with that known defect, we're only going to last for 2 days and then we're going to be off again. So I think that's what I'm saying, that maybe there should be a decision from the organization, is that are we chasing production now? Are we chasing that the system is available, or we chasing that when it's available it is for a long period?
Okay, that concerns company politics and big stuff like that.
Which is not taught in engineering.
Well, it's not really part of engineering, is it? But I believe when it comes to something like that, the engineering says, well, you can't have this thing. Because we know that's our topic area in this business. We know better than you. So we're going to take that now and we're going to make sure that it will. But of course you must be very careful with things like that. Because it must not come back on you such that you were wrong. But
but you can give the management that option. Either you're going to use your left pinky or your right middle finger, and then it's their management decision whether they say they want to take this risk or that risk. You just have to outlay the situation.
To define both risks.
Yeah.
Show them the risks.
But then that's final decision.
That's a good way to say it. The thing is that often people don't believe the risk that you picture. And then when it happens, then they want to make you out as the bad guy. That's unfortunately how it works in maintenance production. Politics, economics, what will we call it?
So does that also depend on the type of process? I would imagine in an industry where it's a batch process, you can afford having more availability with less reliability, because once they need to change to a different batch, they need to wash out the system. So you know, I can run this for 2 days and every 2 days do maintenance on it. Whereas in a continuous process, you don't want to interrupt the production. So you want something that's reliable for longer, that's available for longer periods. So you want more reliability.
I think it's true. For sure. Do you agree?
Yeah, no, I got what it says.
Thus, a measure of the reliability of equipment must be provided. We say that there must be such a measure, and the average uptime is such a measure. Now the average uptime we call the mean time to failure. The mean time to failure. And that's the uptime divided by the number of times that the thing has failed, that something has gone wrong. So we say that if the downtime consists of many smaller occasions of downtime, the availability will remain the same. In other words, when you have your uptime divided by a total time, it doesn't matter how many times that D represents, whether it's 10 or whether it's 1, the availability will be exactly the same. but the mean time to failure, the reliability will decrease because n increases. So if it's 10, it's a tenth of when it's 1. So it's a huge difference. We say that the mean time to failure is also positively correlated with the level of privilege. Then we get to the mean time to repair, but I've still not answered your question about the reliability, whoever. Someone. Okay, we'll get there that way. It's something that I need to do. Mean time to repair. The previous two measures provide an indication of system reliability or the average length of the upcycle. What is needed additionally is a measure of the average length of the downside, which is when it needs to be repaired. This is also called the maintainability of the equipment, and measures the ease with which the equipment can be repaired. In design, it's called the maintainability. So they measure when they design a piece of equipment and they design it for a certain mean time to repair, they call the mean time to repair the maintainability. So they say, well, the shorter the mean time to repair is, the more maintainable it is. In the case of maintenance, in practice, we call it more, it's called the maintenance reaction time. So we say, well, because there's a certain built-in maintainability that was built into the design, but it also depends on us, on maintenance, how fast we react and how will we make use of that maintainability. So that's why we call it reaction time. And that is then the downtime divided by the number of times that it went down. Okay. We say that mean time to repair is not specifically correlated with the level of prevention. And now we come to a thing. And that's where your answer now comes. That's why I say I need to get here. And that is, there we have the relationship between availability, reliability, and reaction time. So we say that availability equals mean time to failure over mean time to failure plus mean time to repair. And that is then, I have a proof there that in the exam I can always ask that, or prove that, but I won't. That's not the reason why I have it there. I have it there simply to show you that it's true. Okay. But I think logically you can just think it out. That the mean time to failure plus the mean time to repair is representative of the full time. And the mean time to failure is representative of the time that it runs.
Now I'll answer my question, sorry.
There's another thing, and that is, what about the mean time between failures? Because that is one that is very well talked about. In literature, everywhere, and even in practice, people talk not of the mean time to failure, they talk of the mean time between failures. And they, in actual fact, they are doing something wrong. It's not too bad a thing that they do. I want to have a piece of crane, and then I want to show you. If I have a failure on the unit, and I repair it, here I have it repaired, then this time here, from failure to repair, is time to repair. And that is the average time of all the times to repair is the mean time to repair. And if after I've repaired it and it runs again up to when it fails, then this is the time to fail. And this total here is the time between failures. So the mean time between failures is the average of the time between failures, which is the total of the two. Because the mean time to repair is so much smaller than the mean time to failure, the error that you make, because what they in actual fact do is they call that one less. But I have to point it out to you that the use of the term is wrong. So whenever you see in the military, when you see in Blanchard, and he talks about the mean time between failures, he means the mean time to failure. So they do it. It's not too bad because the error is not very big, but it's still wrong. Okay. After you've written, I'll go on. So we say that maintenance is more than a cost center. So we've now talked about the influence of different things on profit. Availability, reliability, whatever. We've talked about a few things. And now we come and we say that maintenance is more than a cost center. That's now another thing. Oh no, that's what we were busy discussing. I'm sorry, we made the point already. I don't know why we have this slide. The slide should not be there because we finished with that. The second thing that we want to look at is the maintenance cost balance, where we say, well, when we practice a certain level of prevention, it has an influence on two costs. It has an influence on the cost of prevention. In other words, the more I prevent the more it costs me. Logical. But also, the more I prevent, the less breakdowns I have. So my cost of breakdowns comes down as I prevent more. And when I add the two together, the cost of prevention and the cost of breakdowns, I get the total cost of maintenance, which has a certain minimum somewhere. So we're saying that if we want to strive for the lowest cost of maintenance, we should practice this level of prevention. Okay. What is not true is that we should strive for that level of prevention. Because what we said before, we said that if you can, you must strive for higher availabilities, higher reliabilities, and so on. In other words, if you have to spend money to produce higher levels of availability and reliability so that you can produce more profit, then that should be the option that you go for, and we will prove it later on. But if you cannot do that, then you should go for this minimum cost position. If you know exactly where it is, because it's difficult to know. Especially because this level of prevention is a mixed bag.
So this is more for like when you can only do a batch of 1,000 products, where you've got a limit to your production.
Exactly. Then you would go for this. Absolutely. Yes.
Does the cost of a breakdown include reputation, that kind of thing, or is it just money-wise?
Does it include?
Like, your reputation as a, say Mercedes-Benz as a failure.
Yeah.
Now they lose their reputation as being a good model car.
Yeah.
Now does the cost of breakdown include that? If you get a Mercedes-Benz.
It's difficult to quantify that.
Yeah, but that's what I'm asking, because now you can look just at the cost of the breakdown, but now your reputation also plays.
Yeah, so it's also not only that, but when you're in a production situation, the question often is the cost of breakdown, is it just the cost that it calls to repair the thing, or is it also the production effect?
Yeah.
It depends on how you define this figure. The way I define it is that it is simply, for sure includes the production effect. Yeah.
I think also
No, it's just the cost of
It's just the cost of
Just the cost of the yeah, I'm sorry, I'm confusing myself now. Yeah. No, because you want to include the profit in the next step where we will be going. We want to look at the income loss, we want to look differently than here.
Then you would.
Yeah, so here it's purely cost of maintenance. In other words, maintenance department cost. So if the thing breaks, it costs me a certain amount of money. But in order to prevent that from happening, I can practice prevention, but that also costs me money. Now, where is the optimum? Okay.
So that breakdown is purely your cost of your labour and your parts, not reputation or anything else.
Exactly. Yes, sir.
No, I just wanted to ask a question, but when you answered it,
Okay. So it's now answered. Okay. So the effect of the level of prevention on the production process, that's now where we're heading. So these things that we've already looked at, availability, reliability, and now we've added operability here as well, which is the rate at which the machine can produce, which you also have an effect on maintenance. So the moment that we practice higher levels of prevention, it means that we can have higher levels of availability, reliability, and so on, which then means that you have, in effect, produced extra capacity, production capacity. And that's what we then picture in this picture that I call the maintenance profit impact. And there you have the picture. So what do we say here? We say that I have my output, I picture my output against the cost or against money. This is what is called the classical profit model of an organization. So it's borrowed from there. That exists. So what this profit model says is it says that if I have a certain fixed cost, my organization has a certain fixed cost that does not change depending on output, and I also have a certain level of variable cost that changes. The more I put out, the higher that cost becomes, like raw material costs, like labor costs for producing, and so on. So if I add them together, I effectively take this variable cost and I load it on top of the fixed cost, and I get my total cost line. Now if I produce, my income line must be at a steeper angle than the cost line. Otherwise, I will always be, if you look at this here, your cost is higher than your income. So, again, I have, my income line is the number of units produced times the price. So, it must be a steeper incline such that at this side of the graph here, your income becomes higher than your cost, which means that you will make a profit. So that difference there is a profit at this level of output. Now the idea is that when we produce higher availabilities, higher reliabilities, and so on, we effectively produce extra capacity, which if used, makes for it that you can produce at a higher level of output, which means that this profit line becomes longer, which means that effectively we can book that extra profit against maintenance doing a better job. Or vice versa, if you think like some other people, if you don't do that, you will produce less profit. So that is the profit impact. That's the profit impact of maintenance. And all of this additional profit follows from the those graphs where you produce extra availability and so on. And of course, your maintenance cost is also inherent in this cost profile here, your maintenance cost. So if you do a better job like this, what you will probably find, is you will find that the angle of this will go a little bit steeper. You will get a little bit more cost involved there, which means that this profit line becomes a little bit shorter, but the effect of this, as opposed to the direct effect, is much smaller. So you still win a lot.
So then essentially your variable cost won't be a straight line. The profile will change with the amount of output that you do.
Yes, you see, these lines are very idealistic. It's like in the preventive cost one, where we had the preventive cost as a straight line up. Nobody knows how that line looks. Well, the only thing that you know is that it's an increasing line.
So it's purely display purposes.
Yes. The principles are more important than the actual lines. Okay? And then the total picture I then show like that. So all of these plays a role in this whole picture here.